here we are summarizing the general properties for exponents. So for the following properties, we want to include the initial conditions that a and b are non-zero real numbers. So in other words, a cannot be equal to 0 and neither can b. And we also want to add the additional condition that m and m are both integers. So property number 1. So notice with this first property, we have a to the n times a to the m. So we have the same base but different exponents. So when we have an expression with the same base and different exponents, we can combine those exponents by taking the sum. So let's consider the following example. So suppose that we are given the expression x to the 5th times x to the 7th. So our base in both cases is x, and we can combine those exponents by adding them. So we have x to the 5 plus 7, which leaves us with x to the 12th power. Property 2. So just like with property 1, here notice that we have the same base but different exponents. So we can combine this into one happy exponential expression by subtracting the exponent in the denominator. Or in other words, we have a to the n minus a to the n. So to help us better understand, let's consider the example. So suppose that we're asked to simplify x to the 6th by x to the 4th. Now again, we have the same base but different exponents, and we can combine this or simplify by subtracting the exponent in the denominator from the exponent in the numerator, leaving us with x to the 6th minus 4, or simply x squared. Now with property 3, observe that we have an exponent raised to another exponent. So in this case, with exponents raised to exponents, we can multiply those two exponents together, leaving us with a to the n multiplied by m. So for example, suppose that we're asked to simplify the expression 2 times x cubed squared. So notice within the exponent here, we have two terms. We have 2 times x cubed. So the first thing that we want to do is distribute the outer exponent through to both of our bases. So now that we have distributed the power through the parentheses, we're ready to simplify. We of course know that 2 squared leaves us with 2 times 2 or 4. And here we're going to multiply those exponents together. So we are multiplying our two terms, 4 times x to the 3 times 2, which is going to leave us with 4 times x to the 6th power. Now for these first 3 properties, we were only working with one base. But for the final 2 properties, we are going to incorporate a different base from a. So with property number 4, observe here how we have the product of 2 different bases within the parentheses, both being raised to the power of n. And then we can distribute the power on the outside of the parentheses through to both bases. And this is exactly what we did up here with that last example. And property number 5, last but not least. So with property number 5, again, here we have the ratio of 2 different bases, a by b to the nth power, and we can distribute that exponent on the outside of the parentheses through to each term on the inside. Now, as always, just be mindful that the term in the denominator has to be non-zero, because division by 0 does not exist. And one final example for good luck. So suppose that we are given the expression x squared by 3, all being cubed. So in this case, to simplify, we want to distribute the exponent on the outside of the parentheses through to each term. So in the numerator, we can again see property number 3 coming into play, where we have an exponent raised to another exponent. So we have x to the 2 times 3, which leaves us with 6. And in the denominator, we have 3 cubed, or 3 times 3 times 3, which leaves us with 27.